All right, so today, like I said, we're on page 580, and everybody should have a calculator out as well. We are going to be using angles of elevation and depression to find the distance between two objects. Using angles of elevation and depression to find the distance between two objects. All right, an angle of elevation is formed by a horizontal and your line of sight looking up. Angle of elevation is formed by a horizontal and your line of sight looking up. Thanks. So a diagram of that would be a horizontal line or ray. And if you happen to have a person here, line of sight, if this person is looking up at something, then this angle in here is an angle of elevation. The angle right in here, that angle is called an angle of elevation. It's formed by a horizontal and your line of sight looking up. And then conversely, you can say that an angle of depression is formed by a horizontal and your line of sight looking down. So if you had someone, let's say they were on some type of a platform and this is the ground, and if someone is up here and their angle of depression is formed by a horizontal, so if we draw a horizontal here, and their line of sight looking down now, so let's say they're looking down here, that angle formed right in here. That's an angle of depression. And in this section, you're going to be given the description of a situation. You'll draw basically a figure, and your figure is going to eventually be turned into a right triangle. And then based on if you're given angle of depression or angle of elevation, you're going to use your sine, cosine, tangent ratios to find the distance between two objects, or to find an angle of depression or elevation. Okay? So look at guided practice number 1 on page 581. Here's the type of question you'll get. The crossbar of a goalpost is 10 feet high. If a field goal attempt is made 25 yards away from the base of the goalpost that clears the goal by 1 foot, what is the smallest angle of elevation in which the ball could have been kicked to the nearest degree? Well, you're going to need a little understanding of football in this case, but here's the picture. Crossbar of a goalpost. Well, a goalpost kind of looks like this. All right. You guys have hopefully been to a football game. You've seen the crossbar of a goalpost. Here's what you're told. The black line represents the ground. The crossbar of the goalpost is 10 feet high. So this thing right here is 10 feet high. Field goal attempt is made 25 yards from the base of the goalpost. So 25 yards from the base of this goalpost. Somebody has kicked a ball, okay? They've kicked this ball. It clears the goal by a foot. So someone kicked this ball, and it went through this goalpost, and it went through it a foot above the crossbar, and the crossbar was 10 feet off the ground to begin with. So what's the height of the ball when it cleared the crossbar? 11 feet. So here's this kick. The kick now, the flight of the ball actually represents the hypotenuse of this right triangle that I just drew. Now, since the height of the ball when it cleared the goalpost is at 11 feet, we need to convert this 25 yards into feet. All right? And how many yards are in a foot? I'm sorry, 3 feet are in 1 yard, right? 3 feet in a yard. So 25 yards is the same as 75 feet. And here's the angle of elevation. This is the angle we need. Okay, so I'm just going to call it X degrees. We've got our acronym, SOHCAHTOA. And we're right back to doing what we did in yesterday's assignment, but we had to draw the picture first based on the description. So in relation to this angle, we have the side that's opposite and we have the side that's adjacent. Opposite and adjacent is tangent. So we're going to go inverse tan of 11 over 75. And that'll give us the smallest degree measure that this angle of elevation could be in order to make this field goal. So 11 divided by 75 and second tan to the nearest degree, 8 degrees. All right, so that angle of elevation needed to be 8 degrees in order to clear that 10-foot goal by 1 foot from 75 feet away from the base of the goalpost. Any questions there? All right, let's look at example 2, angle of depression. And in this case, they've given you a picture, so that's very helpful. Search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to the other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to the person to the nearest foot? So the picture that they give you looks like this. You've got an 18-foot measurement here. This down here is the water. They're calling point D right here a 90-degree angle. This is the helicopter. Here's the horizontal. Here's the line of sight looking down at the person in the water. I'm going to put a P here. The angle of depression is 42 degrees. Okay? What is the horizontal distance from the rescuers to the person, to the nearest foot? So the rescuers are sitting here. The person in the water is the second star. This is your horizontal distance. Now, here's what we have to transpose. Angle of depression. If this angle of depression right here is 42 degrees, then this corresponding angle of elevation is 42 degrees. Meaning, what we've got here is across the top of this horizontal, we got this blue line that was a horizontal. We got this blue line that's representing the water level, the water itself. Those two are both horizontal lines, so they're parallel to each other. But what happens is this line of sight from the helicopter looking down, all right, becomes a transversal between the two horizontal lines. And if this angle of depression is 42 degrees, then this corresponding angle of elevation is 42 degrees. Okay, that's always going to be true. If you have an angle of elevation that's 42, its corresponding angle of depression is going to be 42. Because they're both formed by horizontals, and horizontals are parallel to each other. So your line of sight in this case or in any case becomes a transversal. So we're trying to find this horizontal distance from the rescue divers to the person in the water, so I'm going to call it H. All right, so back to our acronym. SOHCAHTOA, we've got opposite and we are looking for adjacent. Opposite and adjacent is tangent. So our ratio, tan 42, is equal to the opposite side, which is 18, over the adjacent side, which is the h, what we're trying to find. So we're multiplying both sides by h again. The h's cancel, and then we can divide both sides by tan 42. The tan 42s will cancel, and our h here is going to be equal to 18 divided by 42 tan. And we get 20. All right, so the diver's 20 feet away from the person that needs help in the water. Everybody okay with that? Let's look at the lifeguarding example down in the bottom of example 2. And they actually give you a drawing again. A lifeguard is watching the beach from a height of 6 feet above the ground. She sees a swimmer at an angle of depression of 8 degrees. How far away from the tower is the swimmer? All right, so this lifeguard, line of sight 6 feet above the ground. So we've got this lifeguard sitting in this stand, kind of looks like this. And this person's got some eyes up here. All right, here's our horizontal. I'm just tracing the, or I'm trying to redraw the picture out of the book. You got this person in the water, I'll call that P again. Here's our person in the water. Line of sight to the person forms our angle of depression that's at 8 degrees. This line of sight right here is 6 feet above the ground. All right, and then this is the ground, which they've got it being level with the water. So this leg from the eyes, all right, from this lifeguard's line of sight down to the ground, that forms the 90-degree angle to make this right triangle. How far away from the tower is the swimmer? So here's the swimmer, the person in the water. Here's the base of the tower. And here's what we're looking for. I'm going to call it H again. All right, so we're going to take this angle of depression. We've got an 8-degree angle of depression. Same as the previous example. And we're going to insert it in here. These are alternate interior angles in the big scheme of things. Like I said, we've got a horizontal here. We've got another horizontal here. They're parallel to each other. And this line from the eyes of the lifeguard out to the person that needs help is the transversal. That makes those two angles alternate interior angles, and they're congruent to each other. So now we're going to work with this angle. This 8 degrees inside. In relation to that angle, we have opposite, and we're looking for hypotenuse. So that's tan again. So we can say tan of 8 equals the opposite side, which is 6, over the hypotenuse. Or I'm sorry, over h. H was a bad example or a bad letter to use here because I'm using an H to represent the adjacent side, but we can handle it. All right, so in this case, to find this horizontal distance, we're going to multiply by h. The h is on the right will cancel. We can then divide both sides by tan 8. The tan 8s will cancel. And our horizontal distance is equal to 6 divided by 8 tan. And we get 42.7. And our dimensions were in feet. So angle of elevation, angle of depression, understanding how they're formed and the relationship to each other. Corresponding angle of elevation and depression are congruent. They're alternate interior angles. And once we get the angle measure in our right triangle, we can use trig ratios to find distances between two objects. Any questions? All right, your practice today will be on page 583. Problems 1 and 2. And then 4 through 7. Make sure you're checking your odd answers in the back of the book. And if you need any help drawing the diagrams, come see me and I'll help you get the problem set up.